Welcome back to class. We are in chapter 5, part 3, the interplay of the IS and LM equation. First of all, the graphical analysis, like we have talked about this before. It is the case that the LM curve is upward sloping in an interest rate income diagram. The IS curve is downward sloping. And with these two curves, we can determine the equilibrium level of the interest rate and the equilibrium level of GDP simultaneously. We can, of course, do that in a graphical way, like we have done that already here in this graph. Equilibrium interest rate is 10%. Equilibrium level of GDP is equal to 2000. But now I would like to compute also the equilibrium income level and the equilibrium interest rate level formally. Let's have a look at the equations. It's the case that we have two equations here, and the first equation is the goods market equilibrium condition, while the second equation is a money market equilibrium condition. In case that something changes on the goods market, GDP will change. But this change in GDP also influences the money market because money demand depends on GDP. This will lead to a change in the interest rate, and the change in the interest rate also influences the investment function. So changes in the interest rate affect the goods market equilibrium condition because now investment depends on the interest rate. So it is the case that there is an interdependency between both markets. Shocks which occur at the goods market, they also have an impact on the money market, and shocks which occur at the money market have an impact on the goods market. Hence, when we want to compute the equilibrium level of income, it is the case that we have to combine both equations. And we will do so by solving equation number 33 for the interest rate. So we are solving the relationship for I. Then we are inserting the relationship into the second equation, into the money market equilibrium condition. And then we are solving for the GDP level. Okay, let's get started. In the first step, we put this minus b2i on the other hand side of the equation. And we are also putting this y on the other hand side of the equation. So this y pops up with a negative sign on the right hand side. Furthermore, we are getting rid of this bracket here. So we get a positive c1y on the right hand side here. And we get a minus c1t on the right hand side. This expression is here. In the next step, we can combine those elements which do not depend on GDP in the square brackets. So the autonomous components are collected in the square brackets, and then we can write minus y out of brackets. So there is a minus sign here. We write this minus sign out of brackets, and we put the y out of brackets. So in these brackets, we have a 1, we have a minus c1 because there is a minus sign in front of the bracket, and we have a minus b1. In the next step, we can divide this relationship by b2, and we have isolated the goods market equilibrium condition for the interest rate. The term in square brackets, that's a very long expression. We would like to abbreviate it. So these square brackets with the 3 dots are defined as these autonomous components. So now it is the case that we will insert equation 37 into the money market equilibrium condition. Let's do it. So in the first step, we put also the autonomous component of money demand on the other hand side of the equation, pops up on the right hand side with a negative sign. In the next step, we are inserting here, instead of I, the expression from equation 37. Then we get to equation 38. We have d1y from the money market condition minus d2, and this expression here is equal to the interest rate. But now we have used the information from the goods market to eliminate the interest rate expression, and we have this expression instead. Now it is the case that we have to do some modifications in order to solve this relationship for the y variable, so that we have isolated a y on one hand side of the equation so that we can compute the equilibrium level of GDP. Let's do that. So in a first step, it is the case that we have here these autonomous components. Like, they do not depend on the interest rate, and when we put d2 over b2 times the square bracket on the other hand side of the equation, this will pop up with a positive sign on the right hand side. So we are left with minus d2 times this minus sign will give a positive sign. So d2, and then in brackets the coefficients which are related to the GDP level divided by b2. Then we can try to write these two expressions here on a common fraction. Therefore, in the first step, we have to compute a common denominator. So we have to construct a common denominator here. We have to multiply through this expression by b2 over b2. Then we have a common denominator, and we can write these two expressions on a common denominator. In the next step, I would like to isolate y on the left-hand side of the equation. In order to isolate y on the left-hand side, I have to multiply through by the reciprocal value of this expression. So I have to multiply through by b2 over d1 b2 plus d2 in brackets 1 minus c1 minus b1. So we are multiplying through our left-hand side and right-hand side by the reciprocal value of this fraction. Then we have multiplied through by b2, and this expression goes into the denominator. Now we can once more use our definition. We use our definition for the square brackets with the 3 dots, and then we get to equation number 42. And here we have an expression for the equilibrium income level. You can see here that the right-hand side does not depend on the interest rate anymore, and all these parameters and variables are known. We only have exogenous variables on the right-hand side, or parameters. And we know these parameters from our numerical example. So this table is constructed in the following way, that in the upper part we have the parameters related to the money market and the parameters related to the goods market. And in the lower part, we have the exogenous variables related to the money market and the exogenous variables related to the goods market. When we now insert all numerical values, in the end, we get the information that the equilibrium level of GDP is equal to 2000. And this, of course, is in line with our graphical examination. The GDP level is equal to 2000. In the next step, I'm going to compute the equilibrium level of the interest rate. Of course, this is also a longer procedure, and we have to perform some modifications. Let's switch to slide number 38. It is the case that we have computed the equilibrium level of GDP already, and we can insert the right-hand side of equation 44 into this relationship here, which stems from the goods market equilibrium condition. So we, in a first step, solve the goods market equilibrium condition for the interest rate I. And now we are going to insert the right-hand side into this equation. Then the interest rate level is equal to the elements which stem from the goods market. And here we have the expression for the equilibrium level of GDP. Now, once more, it is the case that equation 45 just depends on some parameters and exogenous variables. The interest rate does not depend on GDP anymore. We just have to perform some modifications so that we can write the expression on the right-hand side on a common denominator. Let's do so. Like in a first step, we can multiply through this fraction by that fraction. And we get B2 times 1 minus C1 minus B1 in brackets times this square bracket plus D2 times this square bracket with the 3 dots. And here, of course, we also have to multiply the right part of the sum by this expression. Equation number 47 is just the repetition from the previous slide, like 46 is completely in line with 47. Now it's also important that we write these two expressions on a common denominator. So we have to construct the common denominator, and we have to multiply through numerator and denominator by this term in square brackets. When we do that, we can write the whole expression on one common denominator. Then it will be the case that some parts drop out. We have here the square bracket times D2 times the elements in the round brackets with a negative sign. And the same expression pops up in the first part. Like here we have the square brackets, we have D2 and the term in round brackets. This is positive, that is negative, so this will drop out. So we are left with D1 B2 times the elements in the square brackets, which are here, and then minus B2 1 minus C1 minus B1 in brackets times M over P minus D2 in square brackets. In the denominator, nothing has changed. Now we can cancel B2 from the numerator and the denominator, like there is a B2 here, there is a B2 there, and there is a B2 there. This B2 can cancel out. Then we get to this expression, and we are inserting here, instead of the 3 dots, our definition, like the autonomous components. Nothing else has changed. Now that we arrived at equation 50, we can insert like all the different parameters from the money market and the goods market, and the exogenous variables from the money market and the goods market. Then, in the end, we are able to compute that the equilibrium level of the interest rate is equal to 10%. So we were able to confirm that the equilibrium level of the interest rate is equal to 10%. You can see here that this form of analysis is becoming a little bit more complicated and especially time-consuming. It's more time-consuming because we have this interdependency between the goods market and the money market. So in case that something changes at the goods market, it will be the case that the money market will be affected, and in case that something changes at the money market, it will be the case that the interest rate reacts, and this influences the goods market. Due to this interdependency, we have to do all these modifications. But there is one method which will be very nice to use. This method is called Cramer's rule, and I'm going to introduce this method of Cramer's rule so that we can apply this method afterwards. This Cramer's rule is good to solve the following problem. We have two variables which are unknown, x1 and x2, and we have two equations which are given in 51 and 52. And this numerical example looks a little bit like our ISLM model, because also in the ISLM model we have two unknown variables, the interest rate and the GDP level, and we have two equations like the goods market equilibrium condition and the money market equilibrium condition. So it seems to be the case that it helps to have some knowledge about these Cramer's rule. So let's try to have a look and solve this problem. Like we have to solve the two unknown variables, we need to know what is x1 and what is x2. So let's solve this problem by applying Cramer's rule. In the first step, we have to collect our unknown variables on the left-hand side. All other elements go to the right-hand side. So 2x1 on the left-hand side, and then we also put this 3x2 on the other hand side of the equation, pops up on the left-hand side with a negative sign. If this -1 goes to the right-hand side, it pops up with a positive sign. Then, when we put this -5x1 on the left-hand side, it pops up here with a positive sign. Then there is a -4x2 on the left-hand side, and when we put this -6 on the right-hand side, it pops up with a positive sign. In the next step, I would like to write these two equations in form of matrices and vectors. So we have a 2 and a -3 here. You can find the 2 and the -3 in the first row. And then we have a 5 and a -4 here, 5 and -4 in the second row. So these coefficients here are collected in one matrix, which is called coefficient matrix. Then we have here the vector of the two unknowns, x1 and x2, and on the right-hand side we have the solution vector. In the first step, I would like to compute x1 by using Cramer's rule. x1 is in the vector of the two unknowns at the first position, and therefore Cramer's rule tells us, take the elements from the solution vector, like the 1 and the 6, and substitute it into the first column of the coefficient matrix. So in equation 47, you can see here in the first position the 1 and the 6, which stem from the solution vector. Then Cramer's rule tells us, calculate the determinant of the changed coefficient matrix and divide by the determinant of the unchanged coefficient matrix. So in the numerator of this fraction, there is the changed coefficient matrix, and in the denominator, there is the unchanged coefficient matrix. And these two lines here, these lines are not square brackets, but these lines indicate that we should compute the determinant. So we have the determinant of the changed coefficient matrix divided by the determinant of the unchanged coefficient matrix. Let's compute the determinants. We have to compute the product of the main diagonal, 1 times -4, and then we have to subtract the product of the side diagonal, -6 times -3. Same in the denominator, the product of the main diagonal, 2 times -4, minus the elements from the side diagonal, -5 times -3. 1 times -4 is a -4, -6 minus 3 is a +18, 2 times -4 is a -8, and -5 times -3 is a +15. So we get here 14/7, which is equal to 2. So x1 is equal to 2. In the next step, we want to compute x2. x2 is on the second position in the vector of the two unknowns, and therefore Cramer's rule tells us take the elements from the solution vector and substitute these elements into the second column of the coefficient matrix. And then we should calculate the determinant of the changed coefficient matrix and divide by the determinant of the unchanged coefficient matrix. So here we are inserting the solution vector into the second column, and then once more we are computing the determinant. So it's 2 times 6 minus 5 times 1. 2 times 6 minus 5 times 1, and then in the denominator once more 2 times minus 4 minus the product of the side diagonal minus 5 times minus 3. So we get in the numerator 2 times 6 minus 5, which is 12 minus 5, which is equal to 7. Denominator is equal to 7. x2 is equal to 1. Now we can cross-check whether our result holds. So x1 is equal to 2 and x2 is equal to 1. When we insert x1 here and there, and x2 here and there, we can check whether the left-hand side is equal to the right-hand side, which seems to be the case. Also in the second equation, when we insert here x2 and there x1, then left-hand side is equal to right-hand side. Check, we have not made a mistake. Now this part was a kind of refresher for you because you should already be exposed to Cramer's rule. And in the next step, we would like to determine the equilibrium in our ISLM model by using Cramer's rule. So we want to compute the GDP level and the interest rate level by using Cramer's rule. We have two equations, two unknowns. This should work. In the first step, it was the case that in our numerical example, we had to collect x1 and x2 on the left-hand side of the equation, and we were writing the two x1 expression below each other and the two x2 expressions below each other. Same step has to be performed here. We have to collect the y terms and the I terms on the left-hand side, and we have to write the expressions like below each other. First equation is the goods market equilibrium condition. We put this C1y on the other hand side of the equation, and we also put this B1y on the other hand side of the equation. Furthermore, we are also putting this minus B2i on the other hand side of the equation, pops up here with a positive sign. On the right-hand side, we have our autonomous components. The money market equilibrium condition, there we are putting D2 on the other hand side of the equation, pops up here with a negative sign. In the next step, we can write these two expressions in a system of matrices and vectors. Here we have the coefficient matrix. Like we collect all the coefficients which are in front of y and I and collect them in the coefficient matrix. Then we have the two unknown variables, y and I, and on the right hand side we have our exogenous variables. In case that we want to compute the equilibrium income level, we have to check where is our y variable. The y variable is here in the first position. Therefore, we have to take the information from the solution vector and we are inserting these elements into the first column. So we have to take the elements from the solution vector and insert them into the first column because y is located on the first position. Let's compute the determinant. C0 minus C1t plus B0 plus G in brackets times minus D2, and then minus M over P minus D0 times B2. In the denominator, 1 minus C1 minus B1 times minus D2, and then minus the product of the side diagonal minus D1 B2. Now, once more, we have to sort the elements a little bit differently. In a first step, we can put this B2 in front. First, B2 in front, and then the whole element to the front. So we have here the expression minus B2 square brackets, and then also this element here, the minus D2 in front. Then we can put this minus D1 B2 in front, and also this minus D2 in front. In equation 67, it's important to see here that we have a negative sign here, a negative sign there, a negative sign there, and a negative sign there. These negative signs will cancel out, and we have computed here the equilibrium level of income. Now, when we compare equation 68 with the equation 42, then it is the case that the two expressions are the same. So this method, by inserting one equation into the other, gets us the same result as if we use Cramer's rule. So in the last step, we have to calculate the equilibrium level of interest. The interest rate is located on the second position. Therefore, Cramer's rule tells us take the element from the solution vector and insert this information into the second column, because the interest rate is located in the second position. So you can find the information from the solution vector here. Now, once more, we have to compute the determinant. So the product of the main diagonal, which is given here, minus the product of the side diagonal minus D1 times the term in brackets. And then the denominator, you're already familiar with that. In the next step, we also have to sort the elements differently. So we put this term to the front, and D1 goes to the back. So here we find those elements. And then this goes to the second part of the numerator. Then we can also put this minus D1 B2 into the first position, and this minus D2 to the front. Minus D1 B2, and this minus D2 can be found here in the front of this expression. In the last step, we have to see that there's a negative sign here, a negative sign there, a negative sign there. So these negative signs will cancel out. But we have to consider that here is a positive sign, so that this positive sign will switch to a negative one. So in equation number 72, we have a negative sign here between these two expressions in the numerator. When we now compare the equation 72 with the slide 40, equation 50, it is the case that these expressions are the same. So the method by inserting one equation into the other leads to the same result as if we are using Cramer's rule. So we just confirmed here that we have made no mistake by computing this interest rate level before. So we are done with part 3, the interplay of the IS and LM equation. You get to know a new method how to solve a system of two equations and two unknowns, Cramer's rule, and we applied it to the IS-LM case. So this Cramer's rule will be important in our lecture. It will pop up at several parts in this lecture, So you have to be familiar with Cramer's rule. You'll run into those kind of problems several times in this lecture. So especially like now, you should take some time and have a look at this numerical example. This numerical example is very important because it refreshes your knowledge with respect to Cramer's rule. What is not so important is this inserting method. So inserting one into the other. We will not use this method anymore. You can forget about it, more or less. We will not use this method in this lecture anymore because you got to know this Cramer's rule method, and I think that it's much more convenient to use Cramer's rule. So please take some time, have a look at this numerical example, and you should be familiar to solve these kind of problems with Cramer's rule. Thank you very much for attending this lecture. Have a nice day. Bye-bye.